So now the question is that if we have got a scenario where input sequence, system sequence, see now, so this convolution is also expressed by a new symbol called as star. So this is yn is equal to expressed as hn convolve with xn. So two sequences hn and xn are convolved, we get yn. In this is convolution process, since both sequences are to be taken, we need to change one to hk and other we keep as n. So remember, I again repeat that the input sequence xn, system sequence is set by hn only, output sequence is y, right? So yn is convolution of input sequence and system sequence. If input sequence, if you know the system sequence, for any input sequence you can find output sequence. I again repeat, if you know system sequence, then for any input sequence you can find output sequence. Now you have the system but you don't know the system sequence, right? So you have a computer program with executable file. You have a system, you can use the system but you don't know the system. So if in such scenario, for a given system, if you give input, you will be getting the output. If you give different input, you get different output. But you should be able to identify the system. That is called analysis. Based on input and output, you should be able to find. So ultimately the crux is, if I know both sequences, I can find the convolution. So here the idea is we have three sequences yn, we have three sequences xn, hn and yn. So if we know xn and hn, then yn can be found out because it is a straightforward process of convolution. Either xn convolved with hn or hn convolved with xn, both are same things. It is commutative. Now my question is, so if you know this and this, from xn and hn you can compute y. So known, this can be found out. But if you don't know this, you know xn, you have system, you can pass it to the system, you know y. So now the question is, if you know these two, can we find this? What is the equation? Equation is yn is equal to summation k equal to 0 to infinity hk x of n minus k. So I would give you a hint. Can you give some such input that automatically what output you get is a system sequence? So I have system. Having this hn, but this is not known. This is hidden. Computer program is there, but source code is not shown. You give input, you get output. You give xn, you get y. Then listen very carefully. It's very interesting. Not from this electronics stream subject like this, but in general, the beauty of the subject signal system is it is based on common sense. So output is a peculiar weighted sum of input and system sequence. If you know both, you can find output. But if you know input and output, can you find system sequence? So alternatively, I can rephrase the question. Can I think of such input which if I apply, then what output I get is the system sequence itself, and whether that input what I think is very easy and feasible, let us talk about. So Yn is this. Now for what input Yn would be Hn itself. Is it right? So you can alternatively find out what if Hn is equal to, means Yn should be Hn itself. For what input it will happen? 0 to infinity Hk x of n minus k. For what x, for what input sequence, I will be getting this as Hn. लक्षात आलं बघा. मराठी सांगतो. आउटपुट सिक्वेन्स हा इनपुट सिक्वेन्स आणि सिस्टम सिक्वेन्स या दोघांची कन्व्होल्यूशन सम आहे, किंवा इनपुट सिक्वेन्सची सिस्टम सिक्वेन्सच्या वेट प्रमाणे केलेली वेटेड सम आहे. मला इनपुट सिक्वेन्स माहित असेल, सिस्टम सिक्वेन्स माहित असेल, मी आउटपुट काढू शकतो. दॅट इज स्ट्रेट फॉरवर्ड क्वेश्चन. When in reverse engineering, if input sequence is given to you, system is given to you, but system sequence unknown to you, you can execute the system, you can work on the system, but system is not known. Then you have input sequence, you get output sequence. Can you find out the weight sequence? Input sequence, system sequence is also called as weight sequence, so the output is weighted sum. Knowing input sequence, knowing weight sequence, anybody can find output sequence. Knowing input sequence, knowing output sequence, can you find weight sequence? Now, if I have this equation, convolution sum, can I have some special test input which if I give, the output would be system sequence? So I have system with me. System I don't know, but system I possess. I have system, I can use the system, I don't know the system. Can I apply some test input such that what output I get is the Hn itself? So can this be for what xn? For what xn? For what xn? This would be Hn. So Hn is equal to this summation. So this summation I will write like this: H0 xn plus, so sometimes the mathematical jargons like summation, then this is sigma, then some multi-product, this pi. So these jargons make me somewhat uncomfortable. So I write like this: H0 xn plus H1 xn minus 1 plus H2 xn minus 2 and so on. And that must be equal to Hn. So it is like Hn is equal to this summation: H0 xn, H1 xn minus 1, H2 xn minus 2, like this. So what should be my xn? So this should be xhn, means what? So again this is somewhat thinking provocation. So hn should be this, means what? If I put n as 0, if I put n as 0, then H0 must be equal to H0 x0 plus H1 x of minus 1 plus H2 x of minus 2 and so on. This should be. If I put H1, then it should be H0 x1 plus H1 x0 plus H2 x of minus 1 and so on. So H0 should be this, means what should be in this case? Fortunately, what we have got, all previous x less than 0, for which index is less than 0, I take as 0. So this would be H0 would be, if this must be 1, then H0. This is 0, this is 0, this is 0, no problem. Now H1 should be H0 should be this, means what? For this to be true, H0 must be 1, all others are 0. For this to be true, H0 must be 1, this must also be 0, this must also be 0. If I want H2 to be equal to, again the same, this is always valid, H0 x2 plus H1 x1 plus H2 x0 plus so on. So what should be there? X2 should be 0, x1 should be 0, only x0 should be 1. Then both will match. So in general, I have a spatial sequence. I have got a spatial sequence called as, this is called as unit impulse. This is called as unit impulse sequence in discrete domain. We might have discussed on Laplace transform, you might have seen delta t, where delta t is equal to infinity at t equal to 0 and 0 elsewhere. Whereas here I got a spatial sequence xn here such that, or so if I have got only unique if I apply xn such that this is equal to 0 0 0 on back side, 1 0 0 0 on front side. And I put this arrow. Means what? Xn is equal to 1 if n is 0 and it is equal to 0 elsewhere. This is called as a spatial sequence as impulse, unit impulse sequence as delta n. So if you apply this sequence, then what output you get? What output you get is the system function, system sequence. So output sequence is convolution of input sequence and system sequence. So when both are known, you can find the output. But if you don't know system sequence, but you can use the system, then you can apply any input sequence to the system, you get the output sequence. If you apply unit impulse as the input sequence, that is delta n, which is equal to 1 at n equal to 0 and 0 elsewhere, in that case what output you get is the system sequence itself. So if you have unknown, see now, there is unknown system, you can apply input, you get the output. You can apply test input, the output what you get is Hn, and once you know that, you are able to predict for other input what the output would be. So the concept is that impulse sequence is a spatial sequence which convolve with anything results into that thing. So input sequence xn if is delta n, output sequence is convolution if xn is delta n, output is convolution of hn into delta xn, convolution hn and xn, but since xn is delta n, convolution of hn and delta n is hn itself, so yn. So what we get ultimately, the output is convolution of hk x of n minus k. This is also expressed as a direct for symbolic hn convolved with xn. But if xn is delta n, then hn convolved with delta n, the answer is hn. So if x of n minus k is such that it is 0 elsewhere, so xn is 0 elsewhere and only 1 at n equal to 0, in that case what happens is yn, what we get is summation k equal to 0 to infinity hk in fact we can use the property of commutation, means convolution can be expressed like this, it can also be expressed as this is also allowed, and this summation convolution of xk and hk or hn and xn is commutative, so you can write it either hk summation x of n minus k for k running from 0 to infinity, or xk h of n minus k for k running from 0 to infinity. And in this case then what we get, this summation I can write as x0 hn plus x1 h of n minus 1 plus x2 h of n minus 3 plus so on, and this is equal to, since in this case x sequence is such that only x0 is 1 and all other x are 0, so this is equal to 1 into hn plus 0 and so on, so that is equal to hn. So if input is delta n, then the output sequence is the system sequence itself, or you can identify the system sequence by giving a test input sequence called as an impulse. Therefore, an impulse is an input which is 1 at n equal to 0 and 0 elsewhere, which is 1 at n equal to 0 and 0 elsewhere. Now, therefore, in the last lecture I have told that if summation hk x of n minus k for k equal to 0 to infinity, if that for k equal to 0 to m, if that m is finite, it is called as finite system, or it is called as finite impulse response system. What is impulse response? Impulse response is the response of the system for impulse as input. Impulse response is system response. Means impulse response is hn itself. So the system sequence is the output when impulse is the input. So a system for which the system sequence is of finite length, it will mean that if an impulse is applied as input, the output will continue to be there for finite period. If impulse is applied as input for a system for which the system sequence of infinite terms, output will continue to be there for infinite time. So the terms finite impulse response systems and infinite impulse response systems have been used. So the ideas of input sequence, system sequence, output sequence and impulse input are somewhat clear. That's what I feel. Now, there are some standard terms, and everywhere whenever you go, you would be bombarded with the concepts called as linear time invariant systems, LTI systems. And then there are two more things, causal and stable. And in stable you will have BIBO stable, bounded input, bounded output systems. Now, much is talked about these properties. These are very simple, not at all difficult. Rather, I will not spend much time on definitions and all these things because that is quite simpler. You will be able to understand it very easily. Only thing is that its expression and proof is somewhat complex. I will try to make it very simple. So, what is a linear system? What is a linear system? I will try to definition and all that. Now you can, being the privileged students of Google University, you can search for anything and you get the thing in front of you. So I will not spend the interaction time in the very simpler definitions. So linear systems. So what do we mean by system? By system we have got input here, you apply some input sequence, you obtain some output sequence. You apply some input sequence and you obtain some output sequence. Right? So we are again talking of discrete systems, as discrete systems are easier to understand than continuous systems, even though that is not a classical or standard approach. But I think that instead of, as I had already stated, that for all classical things you are supposed to go through the videos of Professor Gadre. Once you go through that, some kind of sufficient background information would be available to you, and in that there will be some voids. You will not be able to understand everything, so that I am filling the void by making the things simpler. Means now it would be unnecessarily teaching the same things in the same classical manner is of no use. It will be wastage of time. And rather, when the standard things are available to you, you should be made aware of those things. You should be informed to use that, and once that is base available, which I told you in the vacation itself, I can fill the missing gaps by making the things very simple, and I am teaching it in non-standard manner so that there should not be any void at all. So the linear system. So input xn, output yn. Now in a definition, sometimes the definitions are very clumsy, and we don't understand what is meaning of it. We don't understand what is meaning of it. What do we mean by linear system? What do we mean by linear system? A linear system means, if you apply, I will give simple example. For a system, if I apply some input, and if I apply it multiple times, I should get multiple times output. If I apply input 1 and if I apply input 2 as their addition, I should get output as the addition of the separate inputs. Is it clear? If I means scaling and additive. Scaling and additivity. These two are required for system to be linear. I am explaining it in simple manner. You can watch the standard videos. So if I have one sequence xn, or as x1n, so I have system. If I apply x1n, I pass it to a system, I obtain y1n. If I multiply this by ax1n, I should get ay1n. Sometime for non-linear system we may not get. Or if I apply another sequence, x2n, I obtain y2n. If I apply x1n, I obtain y1n. If I apply x2n, I obtain y2n. Then if I apply x3n, which is linear combination of x1n and x2n, then for x3n I obtain y3n. Right? Is it clear? So if I apply x1n, I obtain y1n. If I apply x2n, I obtain y2n. Then if I apply x3n such that, which is made up of ax1n plus bx2n, I obtain y3n. If the system is linear, then y3n will be equal to a y1n plus b y2n. A y1n plus b y2n. In that case, system is called as linear system. A system is called as linear if I apply input as x1n, then I separately apply input as x2n, I obtain output as y1n, I obtain output as y2n for these two separate inputs. Then if I apply input which is weighted sum of these two inputs, then what I will obtain some output. If the system is linear, that output would be weighted sum of individual outputs, which means if I apply two separate inputs, I get two separate outputs. If I apply combination of these two separate inputs, I should get the same weighted combination of the corresponding outputs if the system is linear. If the system is not linear, I will not get that. I will get something different. So before we meet for the next time, you yourself think over what we mean by linear and non-linear systems, and you also try to find some examples on your own, and based on those examples you can verify the linearity of the systems, and we will be elaborating it in detail in the next session. Thank you.